percent of the hydrogen, and would be the mass of the hydrogen in 1 mole of the compound. Well, we have each mole of ammonia has 3 moles of hydrogen in there. Each mole of hydrogen weighs 1 gram. So the total mass will be 3 grams, and then the molar mass for ammonium is still 17 grams, and times 100, and that will give you roughly about 18%. So that's how we come up with the percent composition for the elements involved in any compound. So if we know the formula, we can determine the percent composition for each of the elements in there. And same thing you can do with water, H2O. Okay? For every mole of water, it weighs 18 grams. And there are 2 grams of hydrogen in each mole of water, and there's 16 grams of oxygen in each mole of water. So 2 divided by 18 times 100, that will give you the percentage of hydrogen. And 16 divided by 18 times 100, and that will give you the percentage of mass of oxygen. So this is the equation that we need you to remember. Okay, so the percentage of an element in a compound by mass equals to the mass of that element in 1 mole of the compound divided by the molar mass of the compound. Now, how do you figure out the mass of the element in 1 mole of compound? You need to use the periodic table. You need to use the atomic mass. Okay, so some examples that we show here is that we can ask you to calculate the percent composition by mass for the elements in carbon dioxide. And first we need to identify what's in carbon dioxide. Well, carbon, oxygen. Those are the 2 elements in carbon dioxide. Okay, and for each mole of carbon dioxide, you have 1 mole of carbon, you have 2 moles of oxygen. That's what CO2 stands for. Okay, so for now we're trying to get you used to the to express things in chemical formula. You need to understand what is the chemical formula telling you. So in this case, and if you're asked to do the percent composition by mass for carbon and oxygen in a molecule of CO2, we need to know how many grams do we have in each mole of carbon dioxide. Well, in order to determine this information there, we know in each mole of carbon dioxide, we have 1 mole of carbon. Carbon weighs 12.011. We get 2 moles of oxygen. Oxygen weighs 15.9994. We can use 16. So if you add all the numbers together, then you end up with 44.0098 grams. So that's 1 mole of carbon dioxide would weigh somewhere around 44 grams. Okay, and we round it up to, since we're doing the addition there, we keep 3 decimal places there. So we round it up to 44.010 grams. That's the molar mass of carbon dioxide. Now, for each mole of carbon dioxide, we say there is 1 mole of carbon. 1 mole of carbon weighs 12.011 grams. So when we calculate the percentage there, we take 12.011 grams of carbon divided by the molar mass of the compound times 100. That will give you somewhere around 27.29%. Okay, and then calculating the oxygen there. Each mole of carbon dioxide, you have 2 moles of oxygen there. Each mole of oxygen, the molar mass is, the atomic mass is 15.9994. So 2 times that number. That's the mass in grams of oxygen in every mole of carbon dioxide. And then divide that number by the same molar mass of the compound, 44.01 times 100, you end up with 72.71%. Okay. So this is how we determine, well, we could have a compound that has more than 2 elements involved in there. And you do percentage of element, percentage by mass of each element in the same way, using the same formula there, using the same equation. So this is the part where we need you to be able to do calculation. Here's an example there. Okay, we ask you to find the percent composition by mass of magnesium, nitrogen, and oxygen. Now, NO3 is a polyatomic ion, one of the 16 that we need you to memorize. What's the charge on NO3? Negative 2. Well, magnesium is group 2A element. So magnesium bears 2 positive charges. And you got 2 NO3s in there. So NO3, each NO3 will bear 1 negative charge. Okay. So just checking to see if you have memorized that 16 list of 16 polyatomic ions there. Your exam is coming up on Thursday. You need to know that table, okay? And if you haven't get to that point yet, and I definitely need you to take a look at on page 8 of your chapter 2 learning objective, and there's a table on there. And that just so brought to my attention that when you open the document, when you print it out, sometimes the page numbers are different from whichever computer you open it up as to when I load it up there. So this is the first time that was someone told me about that. So when I say page 8 of chapter 2 learning objective, you may just want to view that document on Canvas, so that we have the same page number when we're referring to the page numbers there. Okay. And I'll try to upload it, well, probably this is not something that I can do during the summer there. I'll probably try to upload everything in PDF format. That way, whatever I upload it on the computer, you will open it up and in the same format there. Okay. So polyatomic ions there, and again, we're trying to, every time we have a chance, and we'll try to review some of the topics there, and when we try to determine the charges of the elements there, well, looking in the periodic table, we know magnesium is group 2A, so 2 positive charge, NO3, one of the 16 polyatomic ions we need you to memorize, and each one bears, NO3 bears 1 negative charge there. So, given the molar mass of magnesium nitrate, that's how you name the compound there, NO3 is nitrate, so magnesium nitrate. Now, given the molar mass of magnesium nitrate, 148.3148 gram, 1 mole of magnesium, 24, 1 mole of nitrogen, 14, 1 mole of oxygen, 16. What is the percent for each of the elements in here? Now, when you do this calculation, you have to recognize in the formula of magnesium nitrate, for each mole of magnesium nitrate, you have 1 mole of magnesium in there. How many moles of nitrogen do you have? 2. Oxygen?
6.
5. 6. Yeah, 3 and 2. Now it's at 3 times 2. So you have 6 moles of oxygen, 2 moles of nitrogen, 1 mole of magnesium. So this is the number that you will use in the denominator for calculating the percentage for each of the elements there. Now, this number is going to be, for magnesium, it's going to be 24 divided by 148 times 100. Okay. For nitrogen, it will be 2 times 14, because you have 2 nitrogens in here. So 2 times 14 divided by 148 times 100, now will give you the percentage of the magnesium, of nitrogen. Then for the oxygen, it will be 6 times 16, or 15.9994, divided by 148 times 100. So, using the same equation, and this is the number, this is the answer you're supposed to get. We get 16, roughly about 16% of magnesium, 18%, 19% of nitrogen there, and then 64% of oxygen. Okay, so again, when we're doing the calculation, when we're trying to figure out the percentage of elements by mass, the formula is the mass of each element in 1 mole of that compound. Well, that depends on the formula. How many moles of each element we have in there. The mass depends on the number of moles of each element in there, or in each mole of the compound there. And then the denominator is always the same number here. It's the molar mass of the compound there. So you convert it into a percentage number and you get the answer there. Okay, so that's